May 1, 2024, at 12 o'clock at night, if you look east, you will see this Scutum constellation without a telescope just above the ground. You know, what's the weirdest thing about this constellation? Well, last year, in the month of September, when an Australian research team was detecting some radio signals in the night sky, you know, so that some common objects emitting radio waves, whose neutron stars, pulsars, or their magnetically stronger siblings, could be detected, then surprisingly, they saw a mysterious radio signal coming from the direction of the Scutum constellation, which was not matching any known object. And you know, what's worse, this signal kept flashing continuously for about 5 minutes, and then suddenly disappeared and came back exactly after 22 minutes. Now, after this mysterious incident, when a little more investigation was carried out on this signal, then it was found that this signal has been getting to us continuously for the last 35 years, and yet, we have not been able to find its exact source. Every time, just one message would pop up on the computer screen, match not found. So now the question arises, is there any alien civilization trying to tell us its location through this strange radio signal? Like, kind of saying, hey, we are here. Because, it is mostly possible to repeat the same signal every 22 minutes for the last 35 years, if its source is an unnatural object. An ordinary pulsar or magnetar, for example, slowly loses its energy and stops sending radio signals after a point. So, there is one possibility that maybe it has an unnatural source. Or, the other possibility is that there are some objects in this universe that scientists have not been able to understand completely yet, and these radio waves are emitting from them. So friends, what exactly can these radio signals be? We will have to do a little research on our level. For this, we will have to start the story from the very beginning, that how was this discovered first? Actually, the story of this signal starts from another signal, which was discovered by Tyrone O'Doherty, an undergraduate student at Curtin University in Australia in 2020. O'Doherty was working on a project, under which he was identifying unknown blinking radio signals from the old data of the southern sky. Now, during this project, he found a radio signal from a 2018 data, which was throwing the beam of radio signals towards the Earth like a beam coming from a lighthouse. So, when he told his mentor, radio astronomer Natasha Hurley-Walker about this beam, she herself started researching this signal. First of all, she saw the location of that signal in different frequency data, but unfortunately she did not find any clues about the signal there. But then, she saw a pattern hidden in the radio data. She saw that this signal is being repeated every 18 minutes. And so, she immediately knew that this could be a game-changing discovery of her career. But, unfortunately, before she could study that object in detail, that signal disappeared within just 3 months. And, seeing this unexpected disappearance, she and her team got even more confused. What could this object be? So, to find the answer to this, they scanned the entire southern hemisphere again to find just one clue. And, even after researching for many months, they did not find a clue. And so, they were about to stop their study when they found a signal that was coming back after 22 minutes. Now, after the mysterious disappearance of that 18-minute signal, Natasha and her team started scanning the entire southern sky with the Murchison-Winfield Array radio telescope in Australia. And then, they found another signal similar to the one found in the Scutum constellation near Sagittarius, which kept coming back every 22 minutes. They named it J183910. But, now the question arises, was it related to that 18-minute signal? And, to find out this, Natasha again studied the past radio data of that entire region. Actually, this signal was already detected by the Indian and American radio telescopes in 1988. But, after its detection, that data was lost in a pile of data. And then, during this current study, when this data was revisited again, they found out that this signal has been continuously repeating every 22 minutes for the past 35 years. And, when it comes, it gives a strong radio burst for 5 minutes. Now, interestingly, this was a very good news for the astronauts. Because, with the help of these signals, the astronomers could now know how far that unknown source object is from us. And so, when these calculations were completed, it was found out that this source is 15,000 light-years away from the Earth. That means, now only one thing was left to know, that what exactly is this object 15,000 light-years away from us? So, in this search, first of all, Walker and his team started matching all the known objects that emit radio signals like this mysterious signal. And, surprisingly, they found similarities in the old data and this signal. There were many radio signals in that data that were blinking exactly like J183910, and that blinking pattern was repeating after some time. So, when they researched the source of these similar signals, they found out that all the old signals were emitting from the typical category of neutron stars, pulsars. Now friends, this is interesting. What happens is that when big stars, 10 to 25 times bigger than the Sun explodes, they turn into super dense neutron stars smaller than that instead of becoming white dwarfs. Now, the mass of some neutron stars here is so high that due to gravity, their matter starts collapsing within itself. This compresses the stars and their size becomes smaller. And so, to conserve their angular momentum, these stars start rotating very fast. This is similar to when a ballet dancer pulls in her hand, then the speed of her movement increases. And such rapidly rotating neutron stars are called pulsars. And these are more dense than neutron stars. And because of this dense environment, the neutrons present in pulsars decay in electrons and positrons and start rotating rapidly on its surface. And now, friends, you tell me, a simple question. What is created from a moving electric field? Yes, a magnetic field. And particles present in pulsars like electrons, due to being charged, as soon as they come in contact with this magnetic field, they accelerate in its direction. And during this time, they throw their energy out of the star in the form of radio waves. But the magnetic axis and its rotation axis of a pulsar are not always the same. Just like in the case of the Earth, its magnetic axis is tilted at an angle of 11.3 degrees from the rotation axis. And this is the reason that when pulsars rotate on their rotational axis, then the tips of their magnetic axis emitting radiation periodically point towards our Earth. In other words, we can say that these pulsars blink in one way, which is exactly like our strange signal. So, what does it mean now? Finally all done? Mystery closed? Well, when astronomers studied the pulsars, then they slowly realized that they were on the wrong track from the beginning. Because, usually in study the behavior of pulsars, scientists calculate the emitted signals or their pulsating period, so that they can predict how long the pulsars will be alive. And so, the recently found radio signal, is it really because of pulsars? To know this, scientists plotted all the pulsars on the basis of their rotation period in this graph. Now, the pulsation period of normal pulsars is between 0.25 to 2 seconds. And that's why all the pulsars come here in this region. But because of continuous rotation, eventually pulsars start losing their energy. And now, if the energy is reduced, then obviously its rotation speed will also decrease. And if the rotation speed is reduced, then its pulsation period will increase. And in this way, pulsars will move in this region, which astronomers call the Death Valley. As the name suggests, the countdown of pulsars' life starts as they reach the Death Valley. And basically, the rotation rate of the pulsars in this region slows down to such an extent that they are able to emit radio waves in a small amount of difficulty. And when the pulsars cross this death line, their rotation slows down to such an extent that now they are unable to emit radio waves. But when astronomers plotted the signal that they got in this graph, they were just baffled. Because, as you can see, this signal was emitting radio waves even beyond the death line. So, one thing was for sure, that this object is definitely not a pulsar. But then, they were struck that there is a special category in pulsars, magnetars. That is stars whose magnetic field is 1,000 times more than that of normal pulsars. In addition, they also show a slightly longer pulsation period in comparison to pulsars. And that's why scientists thought that maybe this kind of stars will be able to explain this signal. But when they plotted this star in this graph, they saw that it was not even near that signal. Because, due to being highly energetic, X-rays also emit along with radio waves. But the signal they got was only emitting radio waves. And that's why astronomers had to rule out the possibility of it being a magnetar. That is, all in all, the signal scientists got was neither a pulsar nor a magnetar. And it was clear that the radio signal they recently got was not matching any known object for astronomers. And that's why, according to them, this signal is still a long-standing mystery. But friends, when we were researching on this topic, then we found out that apart from pulsars and magnetars, there is another special category of stars called white dwarf pulsars, which may possibly match this strange signal. Actually, white dwarf pulsars are such white dwarfs that pulsate like pulsars. Usually, white dwarfs are formed by the explosion of a star with less mass than the Sun, and usually, their magnetic field is not as strong as pulsars, and that's why they don't even pulsate. But when white dwarfs become 0.8 times as massive as the Sun, then they become so dense that just like pulsars, they also generate a strong magnetic field. The only difference is that, where neutrons and electrons decay in pulsars, and the white dwarfs are originally made up of electrons. So, as soon as these charged electrons come in contact with the magnetic field, they emit periodic light flashes like pulsars. But their pulsating period, which is opposite to pulsars, is 100 to 1000 seconds. And now, if you remember, the period of the signal we recently got is 22 minutes. If I convert it into seconds, then the period is 1320 seconds. So, even though this value is outside the range of white dwarf pulsars, in comparison to other pulsating stars, this is the closest match of this signal. And that's why, friends, if you ask me my opinion, then I personally feel that this mysterious radio signal is coming from a white dwarf pulsar. That is, with this, you can understand how many things in this universe that we still haven't fully understood. Like even supernova explosions, for example. You all know that when a small white dwarf explodes, it is a type 1 supernova. And then when a star 8 to 40 times heavier than the Sun explodes, it is a type 2 supernova. But recently, scientists have found a mysterious supernova explosion called the Scary Barbie explosion, which has been emitting 100 times more energy than any supernova explosion in the last 3 years. And it doesn't fit into any of these types. Now, if you enjoyed today's video, if you learned something new, then do hit a like. And subscribe to the Science Threads channel and press the bell icon so that you don't miss any of the curious videos to come. See you next time.